Dear student, let us continue with module number 2. In this lecture video, we will be studying the input buffering. Now, as we know that lexical analyzer scans the input from left to right, one character at a time. So, lexical analyzer has to read the input stream, like input character stream. Whatever program a programmer writes, lexical analyzer it has to read, and it will convert it will tokenize the input characters. So how it will read the input characters, input string, character string? It uses two pointers. Lexical analyzer uses two pointers. One is called BP, that is begin pointer, and another is called FP, that is forward pointer. One is called BP, which is begin pointer, and another one is FP, that is forward pointer. So BP and FP to keep track of pointer of the input scan. Now, initially, both the pointers point to the first character of the input string as shown below. So, initially, you can see that both BP and FP point to the first character of the input characters. Now, next, FP will move one character at a time. So here it is moving. In the next step, FP has come to N. In the next step, FP has come to T. So it will keep on moving till it encounters a blank space. Now once it encounters, the forward pointer moves ahead to search for end of lexeme. As soon as the blank space is encountered, it indicates end of lexeme. So here, once the forward pointer, it will move from T to blank space, it will consider, int will be considered as one lexeme. Okay, so in above example as shown as pointer FP encounters a blank space, the lexeme int is identified. The FP will be moved ahead at Y space. When FP encounters white space, it ignores and moves ahead. Then both begin pointer and forward pointer are set to next token. So once the FP will encounter the blank space, then this int will be considered as one lexeme, and then FP will move to the next character I, and BP will also move to the next character which is next immediate after the blank space. Again, BP and FP will start indicating at the same character, that is I, and this int will be considered as one lexeme. The input character is thus read from secondary storage, but reading in this way from secondary storage is costly. So input character like this, it can be read from the secondary storage, but it is very costly reading the input character from the storage. So hence another technology, it is called buffering technique. Hence buffering technique is used. A block of data is first read into buffer and then second by lexical analyzer. A block of data is first read into buffer. A block of data will be first read out. It will be put into the buffer, and then second by and lexical analyzer will read the data from the buffer. There are two methods used in this context. There are two techniques for buffering. One is one buffer scheme and another is two buffer scheme. Two buffer scheme. The let us see. This is one buffer scheme here. So in one buffer, this is one buffer scheme. So in this scheme, only one buffer is used to store the input string, but only one buffer it is used to store the input string. But the problem is that if with this scheme is that if lexeme is very long, then it crosses the buffer boundary. To scan the rest of the lexeme, the buffer has to be refilled. That makes overwriting the first of lexeme. Suppose here int is there only 3 characters, but suppose a very large some identifier is there. Okay, then it won't be adjusted in one buffer. So it need to be, suppose it has a 50 character, then suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. It will consider only 9. The remaining things where will you put? Again, overwriting will happen. So that is the problem with the one buffer scheme. So then we'll go with the two buffer scheme. So to overcome the problem of one buffer scheme, in this method, two buffers are used to store the input string. The first buffer and the second buffer are scanned alternatively. Alternatively, when end of current buffer is reached, the other buffer is filled. When first buffer is filled, then other buffer will start filling. The only problem with this method is that if length of the lexeme is longer than length of the buffer, then scanning input cannot be scanned completely. Here also, but it will solve the length of the lexeme up to some extent, no, but not completely. So here we can see that here buffer 1 is there, buffer 2 is there. Once the buffer 1 is filled, then buffer 2 will start filling. And the last box, it will be filled with end of file. So one end of file it is encountered, then it will be considered as buffer is end. Thank you.